paralyzed patients through eye movement detection. Implement eye tracking navigation system for wheelchairs, enabling individuals with complete paralysis to achieve greater independence and mobility by seamlessly controlling the wheelchair through intuitive eye movements. This solution aims to enhance accessibility, improve quality of life, and foster self-reliance through reliable, real-time, and user-friendly interface. Next, abstract. This project focuses on developing an advanced wheelchair control system using an Arduino Uno microcontroller and Python OpenCV for eyeball tracking. Designed to aid partially paralyzed individuals, the system interprets eyeball movement to navigate the wheelchair in multiple directions like forward, backward, left, right, and stop. So, commands generated by the eyeball movements are transmitted wirelessly through fire-based technology to the motor driver, which then controls the wheel rotations accordingly. This setup provides a seamless, reliable, and user-friendly solutions for enhanced mobility. So the literature survey, and the first title of the paper is offline analysis for designing electrokilogram based human computer interface control for paralyzed patients. And second one is patient specific walking aiding mechanism for a patient with paralyzed hip. It is a case study. And title of the paper. Third one is design and implementation of a nursing robot for old or paralyzed patient person. So the fourth paper is assistance for paralyzed patient using eye motion detection. So this is the title of the title of journal and the year of publication and the discussion what they have discussed in the papers. So the flow chart of this project is first we have to capture the eye movements using OpenCV. Then in that OpenCV we'll be using D library to capture the eye pupils which we will be using to determine which direction the patient wants to go to left, right, forward, or backward. And these movements are interpreted and then which will be sent to through the Bluetooth signal motor controller, and these data will be executed accordingly and like the real-time adjustments.
So myself Vinod, and this is the block diagram of our project. We have kept a battery to provide a voltage supply for the Arduino Uno, and we are using a ESP86 Wi-Fi module. And the input will be generated from the Firebase, where we will be processing the real-time eye movement, and where we will be using a open Python OpenCV and the D library, where we calculating the midpoint and the distance of the eyeball movement. And we are using ultrasonic sensor to detect the object. If any object is detected, it will move backward and stop. And we are using LCD to display whether the wheelchair is move forward, backward, or right or left. I'm using a motor driver to control the DC motors, and this is the wheelchair control mechanism of our project. The software we are using is Python OpenCV and Anaconda Navigator. The hardware we use is Arduino Uno, ultrasonic sensor, motor driver, LCD display, DC motor, and 12-volt battery. The algorithm of our project is step one is initialization. We are calibrating the eye system to map gaze points accurately to navigation commands. Load user preferences for speed, sensitivity, and control options. And step two is gaze data capture. Continuously capture real-time gaze data from the eye tracking system. Map the user gaze position to corresponding navigation command. And step three is obstacle detection. Use environment sensor to collect data about obstacles in the wheelchair conditions. And step four is intent recognition. Interpret the user gaze based navigation command. Check out conflicts between the user intents and the obstacle map. And step five is decision making. Combining the user commands with real-time sensor data to determine safe navigation. And movement execution. Translate the final navigation decision into motor control feedback. The step 7 is feedback and adaptation. Provide feedback to the user about the executed command. And the last step is emergency handling. Monitor sensor for sudden obstacle or unsafe condition. And we are using three modules in our project. And the first one is eyeball tracking, where we'll be using OpenCV and Django for real eye movement tracking, analysis, and visualization. OpenCV captures video stream to detect gaze direction and blinking frequency, while Django processes stores data managed users authentication. And the second one is wheelchair control. An AI model detects eyeball movement, and that information is shared to the wheelchair section automatically move in the direction ultrasonics are used to detect the obstacle in front of the wheelchair. The last one is obstacle detection and safety. The system includes ultrasonic sensor that continuously scans for obstacle in real time. Upon detecting an obstacle, it automatically stops the wheelchair to prevent collision. And this is the output of our project. We will be using eyeball movement detection software which has been developed by Django framework. And this is the output shown in Visual Studio Code, where it's been shown at whether it's which direction is moving, whether it's backward, forward, or right or left. And these are the references we have been used in our project. So thank you.